All right, it's 10 o'clock, guys. Welcome to another edition of the Long Coffee Break. I'm Joshua Likes, Senior Sales Engineer out of the Grand Junction office. And with me today, we're very blessed to have Mr. David DeRocher, Regional Drive Specialist with Yaskawa. And today he's going to be talking about VFD packages. So David, please take it away.
All right, thanks, Josh. So we're going to dive in on some Yaskawa stuff today. Let me get going here. So I want to focus on VFD packages today. And like Josh said, I am the regional drive specialist for Yaskawa low voltage drives here in Colorado, Utah, Wyoming, and Montana. So I'm based out in Denver, and we'll kind of roll through some different packages that Yaskawa offers for the HVAC industry. Right here on this first page, we kind of got the lineup. And so we'll break down first the drive that goes into these, and then discuss enclosures, options that go with them, and kind of how you'd build out a part number associated with these packages. The agenda, I'd like to, like I was saying, start with that first VFD basics, kind of get a lay of the land on what goes into a VFD. We'll talk about just benefits of why you would use a drive in the first place. I'll briefly touch on harmonic considerations. We were talking about this earlier. That could be a whole nother presentation. So maybe next time I'll do a deeper dive on harmonics. But feel free to ask any questions today on what you might have for harmonics. Bypass packages we'll discuss, general configured, the enclosure types, and then again those catalog numbers. So just the first thing I want to throw in, it's always nice to start with basics. And so what is a variable frequency drive? So higher frequency is going to give you a higher speed. Just like you run a motor across the line at 60 hertz, typically with a contactor, you'd only get 0 or 60 hertz. You don't get anything in between. The variable frequency drive allows you to get every conceivable frequency, down to 100th of a hertz. In between that range. And then actually the Yaskawa drives, we can do up to around 400 hertz and above on some models. And then, that's giving you full speed control for whatever application you might be using it for. And typically those fans and pumps, you're going to be able to control flow rate this way. So the main benefits here are energy savings. You're going to get less mechanical stress by basically using this device as a fancy soft start. And then finally, you get network connectivity incorporated into the drive as well. But if you haven't seen it before, this is the general schematic of a VFD. They're very consistent across different manufacturers. Of course, reliability, user interface are going to be the main things that differ. And so starting from the far left, we've got a 3-phase incoming line power going in, and then that gets rectified through some diode bridges here. And then that goes into the center where you see the L and the C. That is our DC bus. And so the HP600, the primary, flagship HVAC drive we're going to discuss today, actually includes a split link choke inside it as standard. And this kind of right off the bat will reduce some of the harmonic distortion that drives can create. Finally, we're going to take that DC bus and invert it on the right side using these fancy switches called IGBTs. And that's going to recreate what is basically a simulated sine wave. This sine wave can then run any induction motor. We're seeing permanent magnet motors come onto the scene as well too. Yaskawa can handle both of them. If you have a permanent magnet motor application, it's a good idea to kind of consult us for that for specific parameters, but generally we can control them just fine. So the applications for this HV600 product, it's going to be any fan or pump type application that we were discussing. So supply and return fans, your cooling tower fans, fan walls, all the way down the list to your pumps and finally your compressors as well. Anywhere you really have a spinning motor, we can use a variable frequency drive to operate it. Something to note on Yaskawa, at least, we only run 3-phase input motors. So if you have a single-phase motor, something real small, like maybe a kitchen exhaust fan that's 120 volts, single phase, that is not where we're going to shine. That's not the market that Yaskawa focuses on for VFDs. That might be better served by an SCR type dimmer switch kind of controller there. But and mainly those big, larger fans for your facility and pumps is what we're going to be aiming it at. So like I said, with energy savings, this kind of breaks down to what we call the affinity laws. So rarely do HVAC systems always need 100% fan or pump speed. And so what that allows us to do with a VFD, instead of pushing against a damper or a valve, we can get rid of the damper or the valve and instead just use the VFD to control our flow. So as you can see, if you drop flow rate in either water or air, CFM, GPM by around 30%, you're going to get a reduction in power of around 65% in electrical power. This is just due to the dynamic nature of forcing an impeller or a blade against a moving fluid like water or air. And it's just a characteristic of most centrifugal pumps and fans. So the VFD takes full advantage of that. When you're backing off speed just a little bit, you get a large reduction in electrical usage. Over time, this obviously correlates to large savings on cost. And this is why VFDs have been incorporated into HVAC systems for decades now, and they've become very reliable at doing so. So, big takeaway again, small change in speed results in a large change in power for VFDs. The HV600 itself is this guy over to the right. So, that's what the drive actually looks like. On the back, you have a heat sink. On the front, you have the drive in this plastic enclosure. And then you have this keypad right on the front. Whether we're talking about a enclosed package, bypass system, what have you, it's going to be this same keypad. And so this keypad has some new features that make it really easy to use. Very bright screen, tactile buttons allow you to use it with gloves. So you can actually feel the button presses. You can go into hand auto mode, based on local or remote control. And then we actually have a data logging feature, which is pretty cool. So I guess the takeaway here on HV600, this new lineup has significantly more intelligence within the drive, allowing you to rely less on external controllers and use more within the drive itself to accomplish what you're trying to do, whether that be PID loop control of a pump or a fan, or you just need to have a node on the network and be able to detect when there's torque coming from a motor. You can do both with the VFD. So along those lines of being able to have something on a node, the HV600 communication options are listed out here. So embedded, what comes right out of the box, we've got BACnet, Modbus, Metasys, Apogee. And then we actually have all of these Ethernet protocols that you can add on to the drive. And these are all available as standard options within our configured units. I did mention, talking about harmonic solutions just a little bit. So like I said, the HV600 has a standard 5% split link choke inside it, which you can think of like, it's kind of like a line reactor, but we're placing it within the drive rather than in front of it. This will help mitigate some harmonic distortion. But in addition, we also offer the option to do a line reactor. So you can kind of protect the VFD from line transients, big voltage surges, not too large. It's not like a RACAP surge suppressor, but it can definitely, mitigate some of those irregularities in whatever power you might have. So yeah, this is an option we have. And just kind of as a view, if we were to place one of these harmonic reactors, in front of the drive, we go from these current spikes, which are very characteristic of a VFD running across the line, to something that's a little bit smoother and less jarring to your facility power. It's going to impact the neighboring facility, neighboring hardware a little bit less now that we add on this AC input reactor. So again, this could be a whole nother PowerPoint. This is like a first line defense of using an input reactor to try to lower your harmonic distortion there. And it is the go-to solution in a lot of cases. So the next point is we've got the drive, right? I was talking about that. What about putting it in a box? It depends on the environment that we're trying to mount it in. And so type 1 enclosures, of course, that's going to be your indoor use, clean and cool, really trying to protect people from sticking their hands into live electronics. Type 12 takes things a bit further. You've got some additional gasketing within the door of the enclosure, and that's going to help mitigate against dusty environments. There's also a small door over the keypad to make that last longer, so you're not getting dust inside it. It is definitely not, protective against water to a considerable degree, so I don't want to give that impression. However, dusty environments, a dusty mechanical room indoors, we could say would be a good, spot to place these. Finally, the Type 3R enclosure is going to be the rain, wind, snow option. So this is a full white powder coat enclosure, very heavy duty enclosure with full intake and exhaust fans with filtering built into it. This is the one you're going to be using for rooftop units. Anywhere outdoors pretty much is your 3R enclosure. We don't have a NEMA 4X at this point, although I think you could do it custom, just, increases lead time, of course, right? But standard options, this is your go-to for outdoor applications. Going further, so the AC600 also comes in a bypass configuration and just the general configured I mentioned earlier. This is kind of the range that we can get with it. Both 200 and 400 volt classes are included here. And we'll keep moving forward. On the configured selectable options, so you put it in a box and then you can add on different options that you might like with the drive. That'd be circuit breaker. You could add on the 3% line reactor like we discussed if you go all the way to the 3R. Each one builds as a tier. So type 1, you can get all this. Type 12, you can get all this plus all this. And then 3R, all of this plus these additional ones. So the question should be, do you require a bypass? Is it called out in your spec is usually how it goes, I guess, or your schedule. And so the bypass is basically going to, like the name says, bypass the drive. So rather than running power through the drive to run your motor, we give you the option to switch over to this bypass contactor. And so in real time, you can press the bypass button and the drive will shift off of running the motor directly through the VFD and will instead close this bypass contactor on the right and actually run power directly to the motor. So the way we set these up in a narrow bypass configuration like shown here is the drive is on top and these contactors are located in the box down below. This is actually a bypass control board that kind of runs the show and can allow you to have this capability of switching between the drive control or running through a bypass contactor. In the same vein, we can also do one with a service switch. My graphics in the last 10 minutes before I was trying to get this going got switched up, and so I'm missing my switch here. But as you can imagine, there'd be a switch right here. Along with your circuit breaker, and then the same contactors we discussed before. This allows you to disconnect power fully from this drive up top if you like. Reduces just, wasted energy by having to keep that DC bus powered up. Just another option, depending on what your spec calls for. And then finally, the last one would be the 3 contactor bypass. And so again, just stick with me here, but imagine there's another contactor here. So we'd have 1, 2, 3 total. And this bypass contactor is very similar to the service switch in that allow you to remove and connect power to the input of the drive whenever you like. And this is done electronically through the control in that bottom enclosure, like I was saying earlier. So this same kind of deal, going with the narrow configuration, trying to go narrow and tall in order to fit more on a mechanical room wall. We break the part numbers down this way. And same as just the regular configured, there are a variety of power options and control options that you can include onto the drive. So basically, bypass, type 1, and then your voltage class, rating of your amperage, and then you can build it out from there. Type 1 enclosed, just like we were saying earlier, all of these additional options are included or not included, but available that you can add onto this part number to build out your unit. Type 12, similar vein, like I was saying, the additional gasketing, good for those dusty environments. And then the Type 3R offering the most comprehensive list of options. All of these are available as well in order to get your configuration where it needs to be. And I'll hand it back over to Josh here at this point. Thanks for your time.
Awesome. Thanks, David. Everybody, please reach out to your long salesperson as far as any questions on applying these drives and what we can do with them. Today's prizes are $100 REI gift card, Fitbit Inspire 3, and a spreadsheet desk sign. Today's winner is, please reach out to your long sales individual to get your gift for you. And then please join us next week with Gary Aldrich. He's going to be doing RayPack experts with core and plus dynamic protection. So thank you, everybody. Have a great rest of your week.